What's up, my friends? We're still continuing with Holder's inequality. In this video, we'll be discussing more examples. In the previous video, if you remember, we just discussed the main statement of Holder, and we solved two simple examples about the Holder's inequality. In today's video, we'll just explore more problems. We'll solve actually some really nice and very famous standard IMO problems about Holder. So I hope you guys are very excited. What are you waiting for? Let's get started. Alright, so our first example is a very famous standard IMO problem. It is IMO 2001 problem 2. So the main statement is the following. We have three positive numbers and we need to prove sigma a divided by square root of a square plus 8bc. This thing is greater than or equal to 1. That's it. Of course, if you look at it, it's a homogeneous inequality, degree 2, degree 1, and degree 1, so it's homogeneous. Okay, let's see how we can handle this question. First of all, what we notice is that we have a fraction here, and of course we know that both Cauchy and Holder are very nice to clear denominators. So of course this should be the thing what we want to try with. So let's try to do either Cauchy or Holder. We have a fraction here, root a square 8bc. So how can we get rid of the denominator? Well, very simple idea. We can just insert it here. A square plus bc. Okay, this is one idea. But of course, if you multiply now these, you'll get a. So probably you don't want to have an a. So maybe you might just think about it, because of course if you just have a, then it will be square root of a. So if you just insert here an a there, then now you just have this thing is greater than or equal to sigma a all squared. Now this is kind of nice. So you replace this thing here with sigma a squared. But the problem is you have now a square root. So actually you did not get rid of this square root. And of course, like usually, you really want to get rid of these square roots because they're really ugly and very hard to deal with, especially with something like this. So this is really not that cool, because although we clear the denominators, clearing roots is more important than clearing denominators. So this is not that cool idea. And actually, whatever you do, even if you apply Holder here, like whatever you insert here, you will always going to need some kind of square, like a square root, in order to clear this. So we're kind of stuck. Whatever we put will be doomed, because we still need to insert a square root. So what exactly can we do? Well, here comes the very, very important and nice trick for Holder. This is especially for Holder. It does not work with Cauchy, unfortunately. So the idea is you have a square root here. You want to get rid of it, but you don't want to insert roots. Well, why don't you use the same root twice? What does that mean? That means you can use the very nice idea of squaring. This is of course equivalent to our main question. But now you can imagine this as two of these guys. So this thing is actually sum of a over square root of 8 square plus a square plus 8bc times another one of it. And as you can see, this is a really cool hack, because we use two of these guys without inserting. Like it's the same, I just used the idea of squaring. So now what I need here, of course if I want to apply something, oh sorry, this one is just sigma a, if I just multiply these guys, this will be just a single 8 square over 8 square plus 8 BC. So that means here I just need to insert a square plus 8 BC. Alright, very good. But now of course we need to fix the a, because a times a is a square. If I insert a third one, then I need to use holder, so that means I have cubic root. So this is not a big deal, I just can insert an a there. And now we are ready to apply holder. If I apply holder, I just get sigma a all cube. So this one is by holder. And from here you can see that this trick does not work for Cauchy, because for Cauchy you cannot of course have 3, you just can have 2. But this we already here have 2, and we need to have a third one to clear the denominator. So this is basically the idea. Now what we need to do, we have now this thing is greater than this divided by this. So now we just need to show that basically it's enough to show sigma a all cube is greater than sigma. Of course you can expand this thing, it's just sigma a cube plus 8 abc. So this is going to repeat 3 times, so 24 abc. Of course this thing is really a piece of cake. Just expand this, you can already see that you're going to get a single sigma a cube plus abc, like here is the weakest thing ever. So this thing actually, by the way, you should be able to expand this like really quickly. This thing is just sigma a cube plus 3 sigma a square b symmetric plus 6 abc. You're just going to have these guys coming. So for sure, you just need to work on the like one of them. If you found out that this is 6, how do you find out? Well, very easy. How can you get an ABC from these guys? 3 ways to pick A, then 2 ways to pick B, and C is already now determined, so 6 ABC. Now once you figure out the 6 here, and of course here just 1, so now you can work out how many ways to get just A square B. Well, it's just 3. So now you're done. You just need to show this thing. And of course by AMGM you have this thing is greater than 6 ABC. So if you just plug it there, you're done. Alright, so that was like an IMO problem 2, but with holder and with this really nice trick that you should always keep in mind. This hack was really nice, that we can get rid of the root by just squaring. We don't have to insert any other root. Alright, so that was our example 1. Let's move on to example 2. Well, guess what, this example is also from the IMO, but this one is IMO shortlist. (2004) A5. Okay, let's see. So here we also have 3 positive numbers such that sigma AB is 1. We need to prove sigma cubic root 1 over A plus 6B is less than or equal to 1 over ABC. Alright, this one is more aggressive. You can see that we have sigma AB is 1, and we have like here some cubic root. This thing is less than 1 over ABC. Okay, what exactly can we do here? Well, like if you look at this, and maybe you might say I want to homogenize it or something, but this is really like difficult here. Here you have degree -3, here you have degree 1, here you have degree -1. One idea that might come to your mind is to replace this one with sigma AB. If you replace it, you will have this thing as whole, it will be linear. So now maybe like it's much easier to work with, but still you have like here cubic root, and you here have kind of degree 3, -3. So it's really like difficult to homogenize. So it's better to just work with it like this. Okay, now what can we do? Here actually we have 2 ideas. One idea that might come to your mind is to, because you have like a sum of cubic roots, we can maximize it using Tito for holder, of course. Remember we said that the regular Tito maximize the sum of square roots. Also, now using the same idea, we can say that sigma cubic root can be maximized using Tito for the Holder version. So you can just, if you remember, it was something like this. A cube divided by x, this thing is sigma a all cube divided by sigma x. So now if you just plug x, y, z as 1, it's going to be sigma a cube times 3 is greater than or equal to sigma a all cube. And that means this thing can make it like this. And now you can, of course, see that why is this true. So if you replace a with cubic root of a, it's going to be like this. So by Tito's, like Tito for Holder, you can just see that you can just simply maximize this. You can replace it by a big cube root and just have 3 sigma of the thing inside. Of course, this will be a very nice idea, but still, if you apply it here, I'm going to get something like, after cubing, 1 over ABC cubed is greater than or equal to 3 times sigma 1 over a plus 6 sigma a. Okay, and of course you're given that sigma ab is 1. You might try with this one, but this thing is really ugly, because you will have here a cube, b cube, c cube. If you expand it, it's going to be a very large degree. Not really sure if this thing will work, but at least it's kind of a nice idea that we tried, because like this should be the first thing you think about if you have a sum of cubic roots. So maybe this idea is a nice one. You might try this and see whether it works or not. Let's try another idea here. We have sigma cubic root. We don't want to just apply this one, maximize cubic roots. We want to like try to play with this one a little. So what we'll be doing here is here we have, of course, cubic root. Here we have ABC. So one idea is just to take the ABC there. So if you try to do that, you have sigma ABC times the cubic root 1 over a plus 6b. You want to show this thing is less than 1. Okay, remember, like Cauchy used to maximize sigma ab, something like this. Now Holder actually can maximize something like this, product of 3 terms. We can maximize this like this. So let's see, can we do that, especially that we have cubic roots? Right now, if we just like how exactly are we going to distribute them? This is the question. Like, what is the a and the b and c that you want, to make here? Okay, one idea, we have 1 over a there, so probably we're going to borrow this from here. If we take this inside, it's going to be a cube. So if we take a single a of them, it's going to be 1 plus 6ab. Now this thing is nice, but now you have actually bc are still there, and you have a cubic root of a square. Now if you apply Tito, Holder, one of these guys were this, then it's really nice, because this is just going to be 1 plus 6 sigma ab, or actually 3 plus 6 sigma ab, which is just 9, because sigma ab is 1. So this thing is nice, but the problem is, what are the other two? Because you have other two, remember? We said sigma abc, something like this. You pick the c, you need to pick the a and b. And now comes the problem, because no matter what you do, it's like really hard to distribute these. You might say something like this. I will pick maybe cubic root. Of course, you can make these as cubic root and cube. But now you have a problem. Maybe you might say a b cube and a c cube. But these are really not that nice to work with, sigma a b cube or sigma a c cube. Another idea you might try is maybe like to pick, not really sure, maybe b, a. Right now we tried to isolate a with b cube. Like you can try other ones, but I don't think this thing or any of them will give you something nice. So we have a problem here. If we take the all ABC, it will not really work. So let's return it again where it was. It was here. Well, guess what? We tried to pick the whole ABC. We failed. But what we really want is to pick just a cubic root of A. If we have a cubic root of A and put it inside, then it's going to make this really a nice thing. So instead of picking all of this, why don't we just pick a cubic root, not just of A, of course, because we need the other for B and C. So let's pick a cubic root of this. So that means this thing is the same as showing. I will pick the cubic root of ABC and insert it here. Of course, I will take the A inside. It's going to be this. And I will leave these guys outside. Let's make it this. B and cubic root of C. Now, of course, this thing is now ABC squared, or basically 2 over 3. That's it. Now, if you look at this, now this thing is really nice, because now if you apply holder, the LHS is less than by holder. You know, this thing, if you apply holder on, it's going to be sigma this thing, which is just 3 plus 6 sigma AB, which is 1. So it's actually 9. So it's 9. And this thing is now sigma A, and this thing is sigma A also. So it's sigma A all squared. And don't forget that, let's actually cube this. If you cube it, you just need to show this. Now, the LHS here is less than 9 sigma A squared. So now our goal is to show something like this. It's enough. Remember, it's not equivalence. To show 9 sigma A all squared times ABC is less than 1. Sorry, A square, B square, C square. Yeah, this is what we need to show. But guess what? Everything is squared, so this thing is equivalent to showing 3 sigma A times ABC is less than 1. Of course, now we have this very simple inequality, and don't forget that we have sigma AB is 1. So if we have sigma AB is 1, this thing is degree 4. Let's homogenize it. This thing is the same as 3 sigma A ABC is less than sigma AB squared. Now this thing is the piece of cake, because actually, if you remember, we just did this in the previous video, literally the same. You can just use the idea that sigma x all squared is greater than 3 sigma xy from A and GM. So this thing here is greater than sigma of AB times AC, which is just this thing, times 3. So basically that's it. This is true by MGM. And we are done. Alright, so again, what was the idea of this question? The idea was, if you apply immediately like the Tito form for holder, it's really not that cool. If you take the whole ABC, you will not be able to also handle it. But why not just picking the stuff that you need? You just need a cubic ABC. If you pick it just a cubic ABC, cubic root of ABC, then this will be like doable here. Then just holder will immediately kill the problem. And now we're done. Okay, now our last example for today. Example 3. This thing is also a very famous USAMO question, actually. From the same year, 2004, problem 5. So here, we're given 3 positive numbers. We need to prove that pi of a to the 5 minus a squared plus 3 is greater than or equal to sigma a all cubed. Alright, what can we do with this question? Again, the first idea is, you see, here we have a pi of sums. So you should immediately remember holder, and especially that it turned to be one bracket to the some power like cube and a sigma. So literally it's kind of holder. However, we have a minus here. What's this minus doing? This will ruin our lives. Like in holder, we cannot have minuses. We discussed that they should be all positive. And what exactly can we do? Even if it was a plus, still it will not work, because if we take, a to the 5 with a to the 5 with b to the 5 c to the 5, this will not give us what we want. What do we want exactly? Like, what is our perfect scenario here? Your perfect scenario to get sigma a to the cube, if you imagine, your perfect scenario is something like this. You want to get a plus b plus c cube. What do you really want? Think about it. You want to have, first of all, 3 brackets. The first one should have just a, b, and c. The second one b, and the third one c. What you really want is something like this. If you have a cube, 1 and 1, and then here like b cube, 1 and 1, and here c cube and 1 and 1. This thing is true by holder. If the LHS was this thing, then yes, you will be done. But it's not. It's like this. So what should we do? Well, guess what? We just said that this is true by holder. You wish that this thing was this, so perhaps you just take this and prove that it's greater than this. If it was, then we'll be done. So that means right now our goal, what we hope, is that this thing is correct. This inequality for like one variable. By the way, how do we solve, like, prove inequalities with one variable? It's really easy. If you are familiar with calculus, then this should be very easy for you. But even if you're not, then usually this thing can be just factorized. This is exactly what we'll try to do. So this thing actually, let's move these to the other side. It's a to the 5. Oh, sorry, here it's a cube. Minus a cube minus a square plus 1 is greater than or equal to 0. Let's catch this guy here and try to factorize it. Well, it's very easy to see that if you pick a square here, or sorry, a cube, a square minus 1, this thing is going to be minus a square minus 1, greater than or equal to 0. We can take a square minus 1, common factor. We will have a cube minus 1, greater than or equal to 0. Of course, these you can factorize them even more. So it's actually a minus 1 from here and a minus 1 from here. So a minus 1 all square times a plus 1 times a square plus a plus 1. This thing is greater than 0. Of course it is. This thing is positive, this thing is positive, this thing is positive. So yeah, this one is true. That means this one is true. And that means that the LHS is greater than this, which is greater than this by holder. So yeah, don't fear the negatives. Just turn them into positives. That was the idea of this question. So sometimes you should think about holder in reverse, as you can see. Not like always this direction, but here we thought about it in this direction, and we just able to get rid of that. So this is a very common technique that you can get rid of something like this, isolated, just like a function of f of a. You turn it into another function, g of a, but this function is very easy to deal with. You just need to guess what is this function, and like usually showing that f of a is greater than g of a is really nice, or it's really easy. You just need to factorize. But the whole difficulty is guessing what is g of a. Here we guess g of a by thinking about holder in reverse. But in other situations, we will see that there is a very important technique we'll be discussing later, which is called the tangent line trick. Alright, so right now we solved 3 not really easy. Most of them are like IMO, Shortlist, and USAMO questions. So as you can see, holder is really important. Alright, so as a recap, today we learned some techniques, some hacks for holder. The first hack was whenever you have square root in the denominator, then you can use this idea of taking, like, squaring everything. By the way, if you have also a cubic root, then you can do the same thing, but cube everything. and you will have this trick in your mind. The other question, the other hack that we learned here was like here basically we don't necessarily need to pick the whole ABC. Sometimes like you need to pick just what you want, and the main importance of this, you just can always maximize sigma ABC with holder. With Cauchy you can maximize sigma AB, but with holder you can maximize sigma ABC, and even like ABCD or whatever. Finally, we learned that sometimes they might give you ugly stuff like this. You can never work with them. So you just turn them into a simpler stuff like this. These are really easy to handle because like you can see just by holder we're done. So your main goal is just to or the main difficulty of the question is just to guess what is this G of A. Here we guessed it in reverse. If we what exactly we want to for it to be very simple. By holder you just need to have AQ plus 2. So this was our function, and then to show it you just need to factorize, and this is really you should be comfortable with. Alright my friends, so that's it for today. Of course we still have another video about holder, so I hope you guys don't forget to like, share and subscribe to the channel, and see you guys in the next video.